We have already explained what non-functional requirements are, but let's go over it again, just in case. So while functional requirements define what the system should do, non-functional requirements describe what the system should deal with. Systems can deal with many challenges during their operation. They can experience a large number of concurrent users, they can experience servers crash, they can suffer extremely high load of requests, and so on. Non-functional requirements basically describe what is the expected environment for the system, with emphasis on edge cases. If you will take a look at the Wikipedia page for non-functional requirements, you will see a long list of those requirements. In real life, however, there are 5 non-functional requirements that we will usually deal with. Those 5 are performance, load, data volume, concurrent users, and SLA. Let's discuss each of them. Performance. Well, that sounds like a simple requirement, right? What is the required performance for this system? Fast. Easy peasy. Well, not so fast. See what I did here. When talking about performance, there are 2 things we should keep in mind. 1, always talk in numbers. And 2, latency and throughput. Let's talk about the first one. When the client asks for a fast system, your next question should be, what is fast? Fast can mean a lot of things in a lot of systems. I've worked on systems where fast meant 30 milliseconds, and on systems where fast meant 5 seconds. The problem is that your client probably wasn't thinking on the exact number, and you will have to help him with that. The rule of thumb is that when there is an end user at the end of the flow, we usually need the task to be complete in less than a second. When working in a B2B environment, that's a business to business, we are usually looking at faster systems that can measure even 100 milliseconds per task. The reason for that is that we, human beings, are less sensitive to sub-second delays, and for us, a data that is displayed in 1 second or 700 milliseconds looks almost the same, while for a software running on a machine with CPU cycles of few milliseconds, this will be a very long time. But again, the most important thing is to work out this number together with the client or system analyst. The second concept is about latency and throughput. Those 2 words define the way we look at performance and give us 2 points of view on it. Let's begin with latency. Latency answers the question, how much time does it take to perform a single task in the application? For example, how much time will it take for the API to save the user data in the database? Or, how much time will it take to read a single file from the file system? You can see that the latency deals with the time it takes to perform a single task. Throughput, on the other hand, answers a completely different question. How many tasks can be performed in a given time unit? For example, how many users can be saved in the database in a minute? Or, how many files can be read in a second? Now let's look at some numbers so we can understand better the difference between latency and throughput. Let's say the latency of saving user data is 1 second. This is quite slow, but let's stay with it for the sake of the discussion. Now, what would be the throughput? Can we know how many users can be saved in 1 minute? The answer is a resounding no. If the application is well designed, deployed on a strong hardware, and knows its way around threads, it might have a throughput of 1,000 users saved in 1 minute. On the other hand, if the code is buggy and there are a lot of memory leaks and no concurrency at all, we want to be able to reach a throughput of 60, which is the latency multiplied by 60, the number of seconds in a minute. So this is the difference between latency and throughput, and when discussing performance, both of them must be mentioned and set. Now let's talk about load. The load non-functional requirement defines what is the load or quantity of work the application will have to withstand without crashing. The exact definition of load depends on the exact type of the application. For example, for a web API-based application, the load will usually be defined as how many concurrent requests are going to be received by the system without crashing. Note that this requirement looks similar to throughput, which defines how many requests can be handled in a specific time unit. The difference between the two is that while throughput defines the time unit, the load defines the availability of the system, meaning the system should be able to handle the load without crashing down. For example, the performance requirement can dictate throughput of 100 requests per second. but the system should be able to handle 500 concurrent requests without crashing, even if those requests will take more than a second to complete. This definition is important, since the worst thing that can happen to a system is to crash under heavy load. Users can tolerate a slowdown when there is a load, but they won't like it if the system will crash and burn. So the best practice here is to always look at peak numbers. For example, for an e-commerce website, the regular load might be up to 200 concurrent requests, but on Black Friday, we are looking at more than 2,000 concurrent requests. In that case, we should plan for the extreme case, because this is when it's more important for our system to be alive and functioning. Next is data volume. This requirement defines how much data in gigabytes or terabytes our system will accumulate over time. This requirement is important for a few reasons. It will dictate what kind of database we are going to use, since not all databases can handle large quantities of data equally. It will also determine what type of queries we are going to write, because a query in a table of 100,000 rows will be completely different from a query in a table of 100 million rows. And of course, it will help us plan ahead the storage we need to allocate. The data volume usually has two aspects. One, how much data is required on day one, and two, what is the forecasted data growth. For example, a system might need 500 megabytes on its first day and is expected to grow by 2 terabytes annually. Of course, the growth period can be different and can be weekly, monthly, quarterly, and so on. Next is concurrent users. This requirement defines how many users will be using the system simultaneously. This requirement is quite similar to the load requirement, which also defines how many requests should be handled by the system simultaneously, but with one big difference. The concurrent users requirement describes how many users will be using the system, not how many users will be performing requests. This distinction is important. When a user is using a system, there are a lot of dead times when no action is actually taken. For example, a user is asking the system to display order data. The system executes an API that goes to the database and retrieves the data. This is an actual action. Now the user is looking at the data. During this time, the system is doing nothing. The API is not working, the database just sits there, and the network is silent. So as you can guess, systems that can hold 500 concurrent requests will be able to withstand a much higher number of concurrent users. The rule of thumb says that concurrent users are 10 times the number of concurrent requests. So if the system should work with 500 concurrent requests, it can support 5,000 concurrent users. But this number actually depends on the type of system and the usage pattern. SLA. The last functional requirement we'll discuss is the SLA. SLA, which stands for Service Level Agreement, describes what is the required uptime for this system in percentage. This term is widely used by almost all public cloud providers. One of the biggest competitions between them is on the SLA. For example, Azure Cosmos DB takes pride with its 99.99% SLA. This is translated to less than an hour of downtime in a year. Take a look at the numbers. The SLA has great influence on the design of the system. For example, a system that cannot be brought down must have a sophisticated update mechanism that won't require turning off the system while it's updating. This is possible, of course, but it has to be designed this way. One important thing to note about SLA is client's expectations. If you will ask the client what is the required SLA for the system, he will usually give you an answer along the lines of 100%, or the famous 5 nines, which is 99.999%. When this happens, I usually tell him no problem. For this, we will need to build at least 3 data centers in different continents with independent and dual power stations and automatic failover between them. What do you say? This generally brings him down to earth, and we discuss more realistic SLA goals. So these were the most common non-functional requirements you will need to have for the system. And again, never start working on the architecture before you have set those requirements.